Before we start writing the code to set up Docker in our application, we're going to take a moment to just work through some definitions and some conceptual understanding of what Docker is. If you've worked with Docker before and you've got a good grasp of this, you can just skip ahead to the next lesson where we'll be writing the code to set up Docker. If you want a refresher or you don't know much about Docker, this is going to be just a simple, quick overview, nothing too intense. Docker can be quite an in-depth topic, so this is not a deep dive, just a quick overview, just so that we can understand what we're doing with it in our application. Earlier on in my development learning curve, when I first came across Docker, was definitely one of those tools that I couldn't quite grasp initially, sometimes conceptually, and it was a bit too abstract, but once I realized the utility of it when it came time to deploy code and working in multiple environments, I learned the utility of Docker, and it's an incredibly useful tool, and it is one of those tools that's widely used in companies of different sizes. I've definitely used in my own projects as well as professional projects that I've worked on. So take the time to learn Docker. It's super, super useful. So if I had to explain Docker in 3 words, I would be simplifying code deployment. You can think of Docker as a tool that's going to wrap up your whole application, your whole code base into a very neat package. And this package in the Docker world is called a container. And this container that will house everything that your code will need to run, plus all the settings, all of the configurations and dependencies. Every single thing that it needs, it'll be housed in this container, packaged into a neat little bundle. So once it's packaged up in this container, the question is like, why does this become so useful? So if you've ever had to work on varying different environments in terms of development, so whether it's on your local machine, which is a Mac, or another machine, which is a Linux machine, or else in a cloud environment on different servers, you understand if I had to set up Node, for example, on my local machine, I'm going to have to do the work to do that and get the right version. And then if I move over to Linux, that installation process of Node is completely different. It's a different operating system. So that can become a bit tedious when you want to quickly port over from one operating system to another for whatever reason. If we have this base understanding of Docker uses these things called containers to package our code into neat little bundles, we can package our code in a way that is configured and can work in the exact same way on every different environment that you want to use that has Docker on it. So whether it's your local machine, a colleague's computer, or in a complex cloud environment, once your code has been packaged in a specified way where you declare how you want it to run, it'll run in the exact same way on all these different environments. And so this provides a level of universality to your application. Instead of trying to, in every environment that you want to run your application on, configure that specific environment, you can just configure your container in a certain way, and then it will universally run on the different environments. And the magic of Docker is that it takes care of all of this hard work, the configuration, the complexity behind the scenes, and Docker provides us with a very easy way to kind of configure this and set it up for our own application. And this allows us as developers, especially kind of just application developers, to focus on creating our applications, writing our code for that, and not getting too stuck into the infrastructure side of things and deploying our code and configuring it on different machines. So we've spoken about this idea of containers, and Docker uses containers, and this is a central concept to the world of Docker. As we've been talking about, containers allows us to standardize our code deployment. You can think of containers as the Docker's universal method for shipping code. And so the analogy here is the shipping containers that we see in the global shipping system. And these giant shipping containers were an innovation that was created in the shipping industry way back in the days. And before these containers existed, shipping companies just received the goods that needed to be shipped from the different customers that were shipping them. All the goods came in different packages and different sizes. As you can imagine, this made an incredibly inefficient system for packing these goods and packages onto the ships. And that meant obviously any inefficiencies will lead to a higher cost, and so shipping was quite expensive until someone came up with the idea of modular universal containers where the customers who were wanting to ship their goods would pack their boxes and their items into the container, and then so they were in charge of setting up their container however they wanted to, and then the shipping company will just stack the containers on their ship in a nice neat row. This innovated a much more efficient way to pack goods onto a ship, and then over the years obviously this reduced the cost of shipping, and it just made the whole system a lot more efficient. So I think this is a great analogy for understanding Docker containers. You can think of that container as a universal method for shipping your code. So Docker provides a container where you can stuff and pack your code however you want to in your own way into that container, And then once it's packed and locked, that container can be deployed onto different environments, consumed in whatever way that is necessary on those different environments. So it provides a level of universality, a level of standardization. Just as the shipping container revolutionized the shipping industry, Docker has provided a lot of innovations and allowed us to do some really cool things in the development world. So we can agree that the Docker containers provide a standardized unit for our software. So no matter what our code looks like, what specifics are we using, Node, Python, Ruby, whatever it is, however we want to configure it, even in the Node, if we're using different versions, everything is going to fit into that container because we declare it that way. And once it's in there, it's kind of standardized. And that Docker container is going to be fully prepared to kind of be sent anywhere and run anywhere. Obviously, you'll need Docker on the operating system that you want to invoke that container. Essentially, and in a nutshell, these containers create a lightweight and self-contained way for us to ship our code. And sometimes I do think this might be a bit hard to grasp if you're completely new to Docker. Like, so what is the utility in this? And I think in summary, we can just say, like, we can pack our application into a Docker container and then we can run that in any environment without compatibility issues and headaches that you would usually face. Why have we decided to use Docker in our particular tech stack? Because Docker allows us to containerize our application and let it run on different environments. This allows us to create and mimic a mini version of a production environment, like right on our local machine. And so this makes testing and development very, very convenient. And for us specifically, where it's going to be super handy is we're going to be working with MongoDB. With MongoDB, you can obviously install it locally on your machine and set up an instance of MongoDB and interact with the database there. However, when you move this over to a staging environment or a production environment, you'd obviously have either Mongo set up on your server, but that's not like the recommended way. There's services like Mongo Atlas, which would be a dedicated hosted instance of MongoDB. And that's super convenient and useful for production environments. But however, that does come with a cost. And so in a development environment, you don't really want to be connecting to your Atlas instance. Well, obviously, everyone can make that decision for themselves. But for us, we don't want to go and sign up for Atlas, put in our credit card details, all of that. We just want to create a local instance of MongoDB. So we can use Docker to package MongoDB in an isolated container. We can mimic a production-like environment. It can mimic a cloud database. And it also just kind of spins up Docker in a self-contained unit. All the files and stuff are in there. And so it makes it nice and neat and clean. And we can also leverage things like volume mounting and networking just to allow us to persist data and use Mongo in that containerized to really make a super convenient way to spin up a database locally. I think we've covered a basic understanding of what Docker is and why it's useful to us. We've just gone through a few slides there. And so enough of me just talking about that. Let's get hands-on and start turning our attention to setting up Docker on our local machine. So that concludes this lesson. I'll see you in the next one where we'll take a look at installing Docker on our local machine. So I'll see you on over there. Cheers for now.